So just to show you where the notes are, you'll just go to our web page, and you'll go into Canvas. It just takes a little bit because the computer's kind of slow. But you'll go to our web page, and then you'll go in your Canvas course. And I put it a couple of places just in case you go different places, you'll be able to find it. Okay. And you might have one or two courses. I've got several, so I'll just find our class just so you can see what it looks like. Okay, it's here. And I'll switch the student view so you'll be able to see exactly what it looks like. Okay, so I do post the announcements here. So the videos are in the announcements. So if you click on the announcements, you can see it. You can read that announcement there. There we go. If I click on the right part there. Okay, and the links are there. You can also download it from there. Just to make it easier too, I've also put them under the modules. So if you go into the modules, you'll see the notes. And if you need a homework packet, you can reprint your homework packet because that's your homework packet. But here's your notes. So if you want to see the first day's notes, it'll just show up here. And you can go through it. You can print it out. You can download it if you need to. Also, the video links are below it. And these assignments, these are going to be turned in. So I have to put them in here so they'll record them in your gradebook, but you can't turn anything in. Once you turn in your homework packet at the end of the chapter, I'll put the grades in. These are just kind of placeholders so you see what assignments we've got in here so far. Once you do things like take your exam and turn in your homework, I'll fill them in your gradebook. So they're there right now. They don't have grades in them. But once we start turning things in, then I'll start recording them in your gradebook. And so just like any other class, and you can view your grades just by looking at your grades here. There's nothing in there right now. You won't see any scores because we haven't turned anything in yet. But that's just kind of a quick overview of it. So again, if you ever want to see your notes or watch the videos, you can either check in the announcements. It goes to your email as well. Or you can look under the modules. And I put them in order under the modules. So you'll be able to see all the videos from there. I just wanted to make sure everyone knows where things are at and where all the resources are. Okay, so let's now go ahead and get started again. But I just wanted to take a quick second just to make sure we all understood where everything was at. Okay, so let's now go ahead and look at 1.7. And 1.7 is the last section of this chapter. So just to kind of give you an idea of what we're going to be doing next week. Next week we're going to come in. We're going to work through any questions that you have out of 1.6 and 1.7 from your homework. Then we'll review for our practice exam that's on there. Then we'll start a little bit out of Chapter 2, and the following week that we've got time to finish your homework is going to be our first exam. So next week will be review. The following week will be our first exam. So next week is going to be review. Following week will be our exam. Our homework is going to be picked up when we take our exam. So we will be, again, finishing up and going over some questions out of 1.7 and 1.6 also from your homework next week. We'll go through the practice exam, make sure we're ready for that exam. And then if we have time, which we probably will, we'll start a little bit out of Chapter 2. And then that following week, I always like to make sure you have plenty of time to review. That following week, then we'll have our exam. And just so everyone remembers, on your exam, you can either have a page of notes or a set of note cards. If you want to have 6 or 7 note cards, or however many you think you need, you can use those, or a page of notes. But again, our exam's in 2 weeks. So let's go ahead and look now at 1.7. And 1.7, we're going to be combining everything together. We're going to learn some new terms. And then we're also going to learn how to use all the properties from the last section together. So let's look at some new terms here. We're going to look at coefficient. And the coefficient is the number in front of the variable. The textbook has more detailed definitions. I like to give you shortened ones you can kind of understand. So when we talk about the coefficient, that's going to be the number in front of the variable. And that's usually called your numerical coefficient. And then we can also look at like and unlike terms. Like terms, well, like terms mean they are the same. The variables are the same. And can be combined together. And once we go through these definitions, then we'll look at examples of each of these. Unlike terms are just the opposite. Unlike terms, the variables are different. And they cannot be combined together. And we'll look at examples here in a moment. So we've got the coefficient, which is the number in front. If there's no number in front, then we know it's going to be a 1. We'll talk about that in a moment. And we've also talked about like and unlike terms. Okay, so like terms mean they are the same. They can go together. And unlike terms mean they are different. So let's talk about the coefficient. And normally they say numerical coefficient. So let's find the numerical coefficient of these expressions. So let's find the numerical coefficient. That's 8s. Let's do each one of these. We'll just find the numerical coefficient for each one. 4x. About a 9xz. And then let's find about minus xy. How about a 2? And how about zw? So let's look at each one of these. So we're going to try to find the numerical coefficient. So we're looking for the number that's in front of each one of these. And if there's no number, it's a 1. And if it's a negative, it's going to be a minus 1. So let's look at each one of these and try to figure out what the numerical coefficient will be. Well, on the first one, what's our numerical coefficient? We look at the number in front of the variable. So in this case, it's going to be a negative 8. So negative 8 would be your numerical coefficient. The next one, we've got a 4x, so that 4. That would be your numerical coefficient. So that 4 is going to be your numerical coefficient there. The next one is 9xz. Well, we're looking for the numerical coefficient. So again, what's that going to be? The number in front. So what would my numerical coefficient be? 9. What about on the right? These are a little bit different. On the right side, look at this one. Now this first one, there's always going to be a 1 there. And that negative, well, that means our numerical coefficient is a negative 1. So that negative there tells you that it's going to be a -1. So in that case, on that one, your numerical coefficient would be a -1. If there's just a number, that's your numerical coefficient, because there's no variable there, but your numerical coefficient would just be a 2. And the last one, well, there's no number, so we always know there's a 1 there. So for this one, your numerical coefficient would simply be a 1. So that's going to be your numerical coefficient there, which is 1. So is everyone okay with what the numerical coefficients are? They're the numbers out in front. And if there's no variable, that's just your numerical coefficient. If there's a negative in front, what is your numerical coefficient? -1. If there's no number, it's a 1. Otherwise, it's just the number out in front. Those are your numerical coefficients. What about like and unlike terms? So we're going to look at the next ones, and we're going to figure out if these are like or unlike. Okay, are these going to be like or unlike terms? So we're going to go through each one of these, and we're going to talk about whether they are like or unlike. So while you're writing these down, let's talk about our definition. What does like term mean? Like term means they can all go together. They're the same. And now they can all be the same. They can all just be numbers. Those are like terms. They can all be x's. They can go together that way. But they have to be the same. They have to be identical, where they can be grouped together and combined together. So if I've got the numbers 5, 4, and 3, those are going to be like terms because they can be combined together. They're all numbers, no variables. So that one would be like. Those are like terms. They can go together. Now, what about the next one? These are all the variable x, but notice the powers are different. They have to have the same powers. So these are different. They would be unlike. And why are they unlike terms? Well, they're unlike terms because the powers are different. So those are unlike. The next one. They all have x's, but this one has a y with it, and this one has a z with it. When you have all those different variables, they're unlike again. Because they cannot be combined together. It has to be just x's only. The next one, see, these are all just x's, right? So those could be combined together, and those are called like terms. So those are like terms there. Those are unlike because that's z. So those are going to be unlike terms there because that's z. And the last one, again, those are also unlike. And those are unlike because we have all these different variables. So that's unlike. So do we now see the difference, hopefully, between like and unlike terms? Now, when we combine things together, they have to be like terms. So they have to be the same. They have to have the same variables so they can go together. And we're going to be looking at things that have different variables, but we've got to make sure they're identical so they can go together. So now we're going to learn how to combine these terms together. So we're going to simplify down these expressions. So simplify down these following expressions. I'm going to close the door. It's a little bit too noisy. So we're going to simplify down these expressions. These are going to be expressions. We're not going to be able to solve them. These are only expressions. No equations. That's in the next chapter. So we're going to learn how to simplify down these expressions. And let's start with a pretty simple one here. How about 4x minus 3y plus 8x plus 9y. How about minus 7z? So we're going to try and combine together what terms. We're going to take the like terms and combine them together. So let me say it correctly. So we're going to look at this and we're going to try to combine like terms. Doesn't matter which variable we start with. We just pick a variable. Usually we start with x because x is usually first. So I want to go ahead and look at the x's here. And so when I look at the x's, I got a 4x and an 8x. So those are the same. They have the same variable. So those are like terms. These now can go together. And a 4x and an 8x, so 4 plus 8 makes it 12x. Not 12x squared, 12x, because they're adding together. So that's like 4 apples, another 8 apples, that makes it 12 apples. Not 12 square apples, just 12 apples, right? Because you add them together, variable stays the same. Now we repeat the process with the y's next. And so what do we have for the y's? We have minus 3y and a positive 9y. And 9 minus 3 makes it positive 6y. And then we've got the minus 7z. Well, it's all by itself, so nothing can go with it. And that's all we can do. So all we're doing here is combining like terms, simplifying down these expressions. So let's try a couple more of these. The next one we're going to have to use the distributive property. So again, simplify the expressions. I'm just writing the directions again because they're on different pages. So we're going to simplify down the following expressions. This one we're going to have to use our distributive property. Distribute that 5 through, and then combine the like terms. So this is going back again to our distributive property. A lot of times students make mistakes with this one. I like to draw arrows when I use the distributive property so that I don't accidentally make a mistake. So this 5 is out in front. Now, that 5 goes through everything inside of the parentheses. So that 5 gets distributed through to the 2 and the 9. It doesn't go to the 4 and it doesn't go to the 7 because those don't have parentheses. So I always like to draw the arrows so we know when to stop. So that 5 gets distributed through. So if I distribute that 5 through, I've got 2 times 5, that makes it a 10x. I've got 5 times 9, that makes it a 45z. And then I have a minus 4x and a plus 7. That 5 didn't go to the 4 or it didn't go to the 7, did it? Right? Because it stops at the parentheses. But a lot of times I have seen students try to to push that 5 through everything. You stop at the end of the parentheses. So the 5 just gets distributed through the parentheses only. Now what can we do? Well, now we can look at it in terms of like terms. So a 10x and a minus 4x. Well, those are the same. They're like terms again. So those can go together. And 10 minus 4, well, that makes it a 6x there. And then we've got the 45z. And then we've got the 7 on the end. Order of these is not really that important. Just make sure all the numbers are there. So if you wrote the 45z first, that would be okay. Normally, though, we write the x first and the highest power first. But if you mix up the order, it's okay because it's all commutative, meaning we can switch around the orders. Let's try another one. Got this to work with. First things first, we want to go ahead and distribute through. So I always like to circle and draw arrows. So I circle that 8, and I'm going to distribute or push it through. And then the 4. Distribute or push it through. The 9 is by itself, right? Doesn't get multiplied by 4 or anything else because the parentheses tell me to stop. So that tells me to stop there. So now I distribute that 8 through on the first two numbers. So 8 times that 3. Well, 8 times that 3, that's going to make that now a 24x squared. 8 times a negative 5. Well, 8 times a negative 5, that makes it a 40x, and it's negative. Okay, what about the next one? 4 goes through, so 4 times 3 makes it a 12. Bring down that x squared. 4 times 2 makes it an 8x. Make sure you bring the x down. And then we have the 9 all by itself. So is everyone okay with how we did that? So we used our distributive property. Now we need to combine like terms together. They have to be identical to use the like terms. So these are going to go first. They're x squareds. So let's go ahead and add them together first. So I've got 24 and 12. Those add together to make it a 36x squared. And you can cross them off if it makes it easier. If you want to go ahead and just cross them off so you know you've used them, you can do that. Now we can move on and we can do the x's. So these can go together. And careful with that 40, it's a minus 40. So minus 40 plus 8 makes it a minus 32x. Gone and gone. And then we have the 9 that's all by itself. So it just comes down. And that would be your final answer on that. So using our distributive property here, and then we're combining like terms together. Let's do a couple more of these. So let's try to do a couple more of these. I'm going to do one where you got a negative in front, so we have to distribute a negative through, and then we'll do some with fractions. So let's do 2 more where we just use our distributive property, and then we'll do some that involve fractions. So again, same direction, simplify the expressions. Let's do a minus 3 times 4xy minus 9xz. And let's do a minus. We use parentheses. How about 8xy plus 2xz. And let's do a plus 9p cubed. So we've got all these different variables here. First things first, we need to do our parentheses because multiplication goes first. And so whenever we have a negative, I always like to circle that negative with it. And remember, we have to distribute through. So that negative gets distributed through here. This negative gets distributed through over here. So distribute that negative 3 through the first two numbers. And minus 3 times 4 makes it a minus 12xy. Minus 3 times a minus 9. Negative and negative. Well, that's going to make that a positive 27xz. When we have a negative in front, what does that do? All that does is change my signs. So that's going to make it a minus xy and a minus 2xz. And then a plus 9p cubed. So distribute through. Now, what we can do is we can combine certain pieces together. But they have to have the same variables linked together. So what we can look at here, bless you, is xy's. Okay, we've got xy's here and xy's here. So those can go together because they have the xy's. A minus 12xy and a minus 8xy. Combining them together, minus 12, minus 8. Again, think about your numbers. I owe the bank $12. I take another $8 out, so I owe them now $20. So that would be a minus 20xy then, because those go together. What about the xz's? Okay, we've got those. We've got a 27 and a minus 2. You can cross them off if it helps, so those can go together here. Positive 27, take away 2. That leaves you with a 25xz. And then we've got the 9pq all by itself. Nothing else can go with it. And that's as far as we can go. Now, why can't the minus 20 and the 25 go together? Because this one's xy and this one is what? Xz. So they are different. You have to make sure they're exactly the same for them to go together. One more and then we'll look at fractions. So let's look at this one. And then we'll look at some that involve fractions. So we want to go ahead and work through this one. First things first, we want to go ahead and distribute that negative through. And then we'll combine like terms as much as we can. So let's go ahead and combine them together here. Rewrite them first, distribute, and then combine. So we have an 8m. We have a minus 4m, a minus 2, a minus 9m squared, and a 5m. You can write these in any order that you want. I usually write the highest power first. So the largest power is going to go first. And then we'll go down to the variable, and we end with the number. So we're going to end with that minus 2. So let's start with our highest power first. And so that's going to be a minus 9m squared. Nothing else can go with it because no other ones are squared. So the minus 9m squared goes first. And that's just the way I normally write things, is the highest power first. Next, what do we have? Well, we've got several things that we can put together. We've got lots of m's here. These can all go together. So however we want to add them together, we can do them separately. I'm just going to go ahead and add across. So we've got 8 minus 4. 8 minus 4, that makes it 4. And 4 plus 5 makes it 9. So I just add it straight across. And that's going to be your 9m there. And then what do we have that's all by itself left over? Yep, negative 2. So there is your final finished answer. And that's as far as you can go. You cannot go any further because these are all different. These are unlike terms. So that's as far as you can possibly go. With fractions, they're going to behave exactly the same. Only thing is, we're going to need common denominators. So let's do some of these with the fractions here. And again, these are going to be simplify the expressions. How about 3/8 x minus 2/3 y plus 9/8 x plus 3y minus 1/4 x. Okay, so this is what we've got. And do not let the fractions intimidate you. They're not going to be that difficult to work with. They're pretty simple. They've got low denominators. We're going to go ahead and combine them together. With fractions, if it helps, you can write them out to the side. I'm going to go ahead and work with the x's first. So let's work with our x's first. So this is the original. And let's look at the x part. So for the x part, what do we have? We look at just the x's here. We've got 3/8. We've got the x there. We've got 9/8, right? X. And then we've got a minus 1/4 x. Well, if we want to add these together, we need a common denominator. And these are going to be very simple to add together. Because the least common denominator of 8 and 4 would be what? Can someone tell me? Would be 8, right? Okay, so all we need then is we need to take that last one, which is 1/4, and we need to multiply it by a 2/2. That way they have the same denominators. So now we've got 3/8 x plus 9/8 x. Multiplying here, we've got then, you see that's a minus, that's going to be a minus 2/8 x. Is everyone okay with that? And you can drop the x's if you want, just remember it's there. So if it's easier for you to not write the x's each time, you can drop those as long as you remember when you write it on the left-hand side, it has to have the x. These all have the same denominator. We can put them all together. So we've got 3 and 9 and a minus 2. Well, 3 minus 2 is 1. Add 9 to it, we get 10/8 x. And what does 10/8 x reduce down to? Can someone tell me? 10/8 x would reduce down to what? Yep, or keep it as an improper fraction. What about the 10 and the 8? Can those reduce down? What do they have in common? They have a 2 in common, right? So I could reduce that down to be a 5/4 x. Well, you could write that as 1 and 1/4. Normally, though, we leave it as an improper fraction. But you've got to make sure that you reduce it down. So take that 10/8 and reduce that down to 5/4. And don't forget your variable x. So that's our first part. Is the 5/4 x there. Now what about the y part? The y part, let's see what we've got. We go back up and look. We have a minus 2/3 and a positive 3. So that's our y part. Minus 2/3 y and a positive 3y. Okay, well, how do we combine these together? Well, we can put that over 1. And we need common denominators. So let's take that 3y over 1. And let's use a 3 over 3. That way we get the same denominators. So rewriting, we now have minus 2/3 y. 3 times 3 makes it 9. Yep. Over 3. And we can put the y on the end. These are the same, right? They both have y's. They can go together. And 9 minus 2, it's going to be over 3. We've got the y here. 9 minus 2, that's a 7. So that would be then 7/3 y. So what's my final answer then going to be? It's going to be 5/4 x plus 7/3 y. That one was a little trickier just because of the fractions. That's the only part and only place where it's difficult. The only fraction one you'll have is number 6. That's the only one that has fractions in it. All the others are just combining like terms together and figuring out is it a like term or the unlikes and what's my coefficient. I am going to look at a couple of questions from your homework just to make sure we understand what I'm wanting on these. So let's go back and look at 1-6 homework. Let's just look at the first one here. Now, this is 1-6 homework. On this first one, there's different ways of looking at it. And we can use our properties to combine things together, just to make it easier. I can do this problem without using a calculator by just saying, let's rearrange them. So let's rearrange it and put those together. Because we can add 1 to that, and that's going to make it 4,000. And then we can leave the 9 and the 11 together. So if I have 3,999, add 1 to it, that's going to make it 4,000. And then that was using my what property? I changed the order, so that was using the commutative property, right? So just use my commutative property, change the order. And the 9 plus 11 makes it 20. And that comes out to be 40/20. So that's all I did there. Rearranged it. You didn't have to do it that way. You could have just added across. But I wanted to show you that I use the commutative property. And I said to switch them, so we can just put those together. Makes it a little bit easier. And then that's going to then allow me to get the sum quickly. Then question number 2, we've done one like that in your homework. We distribute that through. Okay, we did one already like that. 3 is just multiply all those together. Find that product. 4, use your distributive property. So distribute that 3 through. Question 5. When you take 1 times anything, what does it become? It doesn't change, right? It stays the same. This is an example of a multiplicative identity. Because when you multiply something by 1, it doesn't change. So that's about all I can say on that one. Okay, multiplying that through by 1 doesn't change it, so it's going to be the same. Question 6 we've talked about. All you do is distribute that negative through. So draw your arrows and distribute it through. Question 7. They want you to fill in the missing pieces here. So you're missing the piece here. So you just see what number you're missing and put it in. Question 8, you'll distribute that negative through. Question 9, you'll distribute that negative through. 10, same thing. Now 11, figure out which property it is. I'll give you a hint on this one. When you multiply 1 by any number, does it change? No. So you should know what that one is now. When you multiply something by 1, it doesn't change. It keeps it the same, which is one of the properties. 12 and 13, distribute the negative through. Okay, question 14. What's happening on 14? I'm not changing the groupings. I'm changing the what? Order, right? So which property goes with order? Well, you should know that one. We're changing the order. And 15, you can rewrite it so you can do the sum a little bit easier. You can rewrite it so that 4 and that 1, so that 194 and that 6 go together, and that 76 and that 4 go together. So just add them up. Question 6, we're going to use the distributive property. It says choose the equivalent expression. So we can move that around. Okay, so that 3y squared, that could go to the front. So look at these, and there's one of them that's the same, because you can switch the order. The order can be changed. 17, just add them across. 18, I'm not going to directly tell you the answer for 18, but when we look in our textbook at all of our properties, do any of the properties, do they have negative numbers in them? Do they ever work with subtraction? Any of the properties have subtraction in them. When we looked at the commutative property, the associative property, all of those, none of them had negative numbers in them, did they? Right? So, do you think it's going to work for subtraction? No. Why not? Because none of the properties have negatives, except the inverse. That's the only one. And we look at the negative on the inverse. But otherwise, our properties only hold for multiplication and addition, not subtraction and not for division, because you can't switch things around like that. And 19, fill it in and tell me what property was used here. And 20, use your distributive property. So on 20, just distribute through that 3 in each one of these and see which one matches up to that original. So 20 is just distribute through all the answer choices and see which one gives you that. And we also went through 1, 7. And 1, 7, question 1. What are some word phrases that mean multiplication? And there's lots of them. I mean, you can just list a couple of them. There's product, there's times, all of those will work. So just tell me one word or a couple of phrases that you can use for multiplication. So that can mean product, times, quotient, or not quotient because that's division, but all those mean multiplication. 2 and 3 combined together. 4, just tell me if they're like or unlike. Question 5, we want to find the one with a numerical coefficient of 4. And there's only one of those, so which one has a 4 in front? Not a 4 squared, just a 4. So I can tell you it's not going to be C, because that's got the 4 squared. That would be 16 in front. We want a numerical coefficient of 4. So there's one of those that has a 4 in front, and that's going to have a numerical coefficient of 4. Question 6, we did one just like it a few minutes ago. 7, we talked about like and unlike. 8 and 9 are just find the numerical coefficient, so the number in front. 10, rewrite this using words. So 4 times m minus, whatever. Write it in terms of words. So this one, just take this expression and write it in terms of words. So you could say something like 4 times m minus the quantity m plus 16. Whatever you want to write so that it's the same thing. Question 11, we've talked about that one. 12, again, lots of different terms mean addition. Sum, plus, all those will work. 13 is just look at it and tell me if they're like or unlike. 14 is just tell me some words that mean subtraction. 15 is giving the numerical coefficient. 16, same thing. 17, numerical coefficient. One I'm going to look at, though, is 19. So I'm going to go ahead and look at question 19. Just to make sure we understand how to handle this type of question. Okay, so there's different ways of handling this question. I would just use a calculator. You can combine things together. What I would do is I would do it as easy as possible, and I would just use my calculator, and I would distribute that through first. Because I would work on the inside and work my way out. So I would go ahead and distribute that 0.02 through. So that's going to be 0.02x. And then for the next piece, when we distribute through here, we know it's negative. And so 16 times 0.02, that's going to come out to be 0.32. And I'm not going to finish it because I'm going to leave it for you to do. But what you'll need to do next is then distribute your 100 through. So that's about as much as I can say on that one. So I did the inside. Okay, so I did it first. And then once I got to this step, we'll just take each one and multiply it by 100. And that just moves your decimal place back 2 spots. And I'm not going to finish it. You can finish it. That pretty much now finishes up that first chapter. So what's our homework for next week? Well, our homework for next week is going to be 1/6. You should be able to do them all now. And 1/7. You should be able to do them all also. Next week, we're going to go over questions out of 1/6 and 1/7 from your homework. We're going to spend about 45 minutes to an hour looking at that practice exam and questions that we need to on that. Then we'll start a little bit out of chapter 2, and then our exam will be that following week. Now, we've got plenty of time to digest the material, so our exam is going to be in 2 weeks then. And again, don't forget you can always view those notes online, so just go into Canvas, and I'll have them posted right after class.